Great Lakes as a region is a very large geographic area and comprises, roughly speaking, about a quarter of the country's gross domestic product, sort of as from an economical perspective. There's a lot of major cities in the Great Lakes Basin. There's an image there in the upper left-hand corner of Cleveland, for example. And it's a primary source of drinking water, which is a huge factor that we consider in our research program for this region. There's a lot of recreation and tourism, including surfing, but also a lot of fishing and boating and beach going. Marine transportation is a big issue in the Great Lakes. Shipping around the lakes and vessels coming in from the ocean. And it's tied closely to other activities going on in the basin, whether those be streams, upstream of the river, animals passing back and forth, fish traversing those areas, or the agricultural in the region. So for those of us who live in the basin, there's a lot of close interaction with the lakes themselves, and everybody likes sort of going to the beach, as they say, as well. For us, GLERL, the Great Lakes Environmental Research Laboratory, we have a couple of locations or facilities. The image at the top is our main laboratory in Ann Arbor, Michigan. It's a building that houses laboratories, offices, high bay work area. We have a lot of research that goes on in that area. And then in the image below is our Lake Michigan Field Station, and that's really that's situated on the water. That's Lake Michigan in the background, and so it's more oriented to. It's a series of 3 small buildings there on the sort of middle and right-hand side of that image, and those are some of our vessels in the foreground. We're located adjacent to a Coast Guard facility there, so you can see the black vessel and the one next to it there as well. Those are Coast Guard. Black hulled vessel. Those are Coast Guard resources. So we are located right at the pier in Muskegon, Michigan there. And you can see here what the vision and mission for GLERL is. But it's really to focus on research around Great Lakes and coastal ecosystems, focusing on a variety of subject areas: observing, modeling, field work, predicting what's happening in the lakes. We're a research organization, and you'll get a sense for that today. The other thing we are, particularly in Ann Arbor, is a regional hub for NOAA. As far as I know, it's the largest NOAA facility in the Great Lakes. Not only are we located, GLERL, there, and we maintain the facility, we have a lot of in-house partners that are located there. So it makes for a lot of dynamic interactions across the agency. One organization that you might be familiar with, or is similar to CCME, is our Cooperative Institute for Great Lakes Research. It's a research consortium led by the University of Michigan, focused on research. It's very similar to or supporting our mission at GLERL. We're also the home to the Regional Association for IUS. The IUS is the Integrated Ocean Observing System, headquartered out of the National Ocean Service. Their grantee, GLOSS, and you can see their logo there, is located in our facility, and we work with them on deploying instruments and disseminating data and things of that nature. We have partners in the building from a number of other NOAA offices, including NCOS, Office of Response and Restoration, National Marine Sanctuaries Service, the National Marine Fisheries Service, particularly it's their Office of Habitat Conservation. They're doing habitat restoration projects around the Great Lakes. Sea Grant from the Michigan organizations that are located, as well as our regional coordinator who works across all NOAA entities to coordinate amongst NOAA partners. And we do have some other partners. We have a lot of visitors who come in, emeritus staff, volunteers, people in a variety of capacity come to do work or come for meetings and things like that. As an example of that, it's a great place to work, in my opinion. We have some great conference facilities, and we hold lots of meetings, research-oriented meetings, but also meetings that might be centered around policy issues central to Great Lakes. topics. You can see here in terms of this slide gives an overview of who comes and visits our facility in Ann Arbor and where they're coming from. That includes our partners, and you can see a lot of our visitors are other federal agencies like USGS and the Army Corps of Engineers, which is the red logo, and a private company which isn't too far from us called Limnotech, which we partner with, as well as University of Michigan staff. And as I mentioned, they are primarily reflected by our Cooperative Institute partners. You saw in the previous slide about our Lake Michigan field station, where it is located, or the view of it at least. It's the home port of our vessel operations, really is the focus there. There is a laboratory facility and a couple of scientists out there as well who do a lot of field work. It is located on the water, and we have it's the headquarters of our fleet of small boats. We have around 10 boats. That number fluctuates year to year as new ones come into service or old ones go offline. We do a lot of planning for vessel cruises, engineering support, marine engineering for these vessels. You can see 3 of them in this image here, and I will go through them in a little more detail. And there's a shot at the bottom of how the field station looks as you're coming back into port. All of our vessels, our larger vessels, are using biodiesel actually as part of our green initiative in order to operate. We do maintain vessels during the season, which is just recently wrapped up for the most part. We pull the vessels out of the water in November, roughly speaking, except for maybe our largest vessel, and then it goes back. They go back in the springtime. So winter, we'll be entering our maintenance phase, and then when they go back in, we're in a variety of locations. Here you can see in these red stars around the Great Lakes where we have vessels permanently stationed, and then in some of the blue stars, areas that we go visit for specific mission reasons. So we have a crew of captains that move these boats around the basin in order to meet our scientific needs. Our flagship vessel is the small research vessel Laurentian. It is an 80-foot vessel. It's a multi-day, multidiscipline scientific research platform. It's really where we deploy a lot of our ecological research surveys. We do long-term, well, you might hear me refer to this program a couple different times, long-term research monitoring, where we go out and collect samples of what's going on in the water column. Plankton survey system, we use that device to identify what types of plankton are at different depths in the water column. We have a mock nest, I'll highlight that in a little bit, and as well as deploy autonomous vehicles or instruments or collect water samples, deploy buoys, retrieve buoys sometimes as well, and do study of benthic organisms. So this vessel is home ported in Muskegon, but it does move around the lakes depending on what is planned for that cruise year. We have several boats in a slightly smaller class. These are all around 50, 55-foot vessels, used primarily for support of buoy deployments, instrument deployments, recoveries, autonomous vehicles, dive support, particularly for the 50-footer Storm, which is in the lower, you can see the folks diving off of it in the lower left-hand corner. That's up in Alpena at the Thunder Bay National Marine Sanctuary, typically speaking. Also does a lot of hydrographic survey work up there in order to map conditions around the sanctuary. In particular, they are monitoring the condition of archaeological shipwrecks in the sanctuary, and they need to map those. We do have a fleet of smaller vessels as well. We're doing nearshore work and sampling, or doing some additional hydrographic survey work, and can sort of use them as our mission requires. So that's sort of like an overview of the GLERL infrastructure. But I want to spend most of the time today, now that you have a sense for where we are and what our resources are, how do we use those, and what research do we do? Most of our work is focused on the Great Lakes. It's not exclusively that way. But you'll probably see a lot of that in the slides I've pulled together today, and looking at the topics that are of most significance to us. One of those being invasive species. You can see the piles on the ship deck there. Those are invasive mussels, zebra or quagga mussels, freshwater mussels, that are not a native species, and they're having a big impact on the food webs of the lake. Harmful algal blooms are a huge issue for us. Microcystis is the algae, blue-green algae that creates a toxin. It not only impacts the ecology, but the Great Lakes are a source of drinking water for many communities and cities. You may recall in 2014, there was a shutdown of the drinking water intake system for the city of Toledo for a couple of days. It's not good when you turn off drinking water supplies for around 500,000 people. So that was because there was toxin from this algae entering the system. Now there are things you can do about that, but we're doing a lot of research to understand what causes the toxicity, how to manage these blooms, what are the drivers of it, etc. How does it interact with the invasive species like the algae who are changing the environment and changing the plankton that are competing with these algae. I mentioned earlier how the lake levels fluctuate over time. That has a big impact on marine navigation, but also coastal hazards and recreation. And then the long-term trends and seasonal trends of climate. Ice is a big deal on the lakes. It's something that we track, monitor, observe, and predict. It impacts not only conditions for marine transportation, also recreation, if you're an ice fisherman, for example, but also what happens to the long-term lake levels, because that will alter the amount of evaporation from the lakes. And in order to do this research, we use a variety of types of technology. We've established eddy covariance stations at lighthouses and on one commercial vessel, the Whitefish Bay you see in the picture there. And the purpose of those instruments is to actually observe the rates of evaporation from the lake so that we can try to close the water budget for the lake. We want to understand how much water is going in and how much water is leaving the system. And so it's an active area of research. In the middle is an ESP, or an environmental sample processor. This is in support of our omics research capacity. And it's basically a laboratory in a can. You deploy it within a housing. We have this one typically deployed. This is our original device. We have acquired 2 more this year. And we deploy it in this case, near the Toledo water intake. And it collects samples and analyzes them for microcystis, the toxin that microcystis produces, in order to give updates on a 6-hourly basis throughout the season, or the HAB season. And I mentioned the mock nest earlier. That's the multiple opening and closing net and environmental sample system. So if you can see, there are a bunch on the right-hand side. There's a bunch of fabric here. That's the net on the back of this device. And in the front, it looks like there's a lot of slats. Those actually open and close. And so as you tow this device through the water at different depths, you open one of those nets or close it, and then you can collect samples of the plankton at those different depths and then compare them to each other after the end of your cruise. That device is used at a number of NOAA facilities. I know they have one at AOML, for example. And so those are some of our research topics, and our communications staff was very helpful and great in putting all these slides together, highlighted a number of what we call our core competencies. And I mentioned some of these already: harmful algal bloom research, forecasting the water level of the lakes, the hydrology of the basin. We work a lot with the Weather Service on that. A real-time environmental coastal observing network, a recon system that's putting out our buoys. We do modeling of the conditions in the lake, hydrodynamic modeling to create a coastal forecast system. I'll highlight that in a little bit. Our regional fleet, communication outreach. Coast Watch is part of our remote sensing research program. It provides different products to the public, invasive species, ice research monitoring, and as well as long-term ecological monitoring of the lakes, and then of course climate impacts. So GLERL is organized. Hang on, let me drink of water. GLERL is organized into 3 research branches, and so I'm going to go into those one by one. The first one is called IPEMF, or the Integrated Physical and Ecological Modeling and Forecasting Group. So what IPEMF does is they're really our team of modelers, and we have researchers with a variety of areas of expertise looking at the entire atmosphere, lake, ocean, hydrologic interactions, considering things like circulation, waves, evaporation, already mentioned, runoff, maybe I got disconnected from the thing.
Okay, we should be back now.
All right. Sorry to have disconnected. Hopefully you didn't. I mean, you really missed an exciting part of this presentation. Oh wait, it's still loading.
What is the daily cost of your big ship?
If you want it, so we do work with a lot of our partners to come and use our vessels. Daily rates for our 80-foot vessel is probably in the range of, well, I don't want to quote you the wrong one because you're a NOAA partner, but it would be in the range of $2,000 to $3,000 a day, something like that. It would depend A lot of times we partner on those costs. It depends on what the research project is, what needs to be done, maybe where the vessel is going. But we do a lot of work with our Cooperative Institute, particularly because it's a consortium of 14 universities. And sometimes we may use their vessels, or we may use vessels from the EPA as well, which are in the lakes, depending on what the project is doing and where it's located. You know, we have one research vessel, but it takes a long time to get from Michigan to the far reaches of Superior or across Lake Erie, and so we can't be everywhere at once. So that impacts our vessel strategy. Okay, let me go forward into our modeling. Okay, good. So I mentioned the oil spill issue, as well as our harmful algal bloom tracking. So these two images on the right show output from our circulation model. The top image is model output. The currents are these arrows, as well as the model grid, which you might be able to see there faintly. And it's on top of an image of what the algal conditions are like at that point in time. And that's used to inform forecasting of the HABs. On the bottom image, it's a hypothetical oil spill where there's a pipeline between Lakes Michigan and Huron. And so where would potential oil particles go? And that's a snapshot of a trajectory. And I suspect the colors are probably the age of the oil that's been released. The modeling that we develop here, we work closely with a lot of other NOAA partners. We're a research part of NOAA. And if what we develop is valuable and useful, we can't necessarily maintain it forever. We transition that over to an operational part of NOAA. So this modeling goes, the circulation modeling goes to co-ops, and the National Ocean Service as part of their operational forecast system. So we're moving around the lakes and continue to upgrade those models using FECOM. What's next from that modeling perspective? We have historically a structured pond model for the Great Lakes. Sorry. Did it kick me off again? We're moving to an unstructured FECOM model. not work great in the Great Lakes. So we often need $15 or $20 years in the Great Lakes. It's likely that it's a great example of an issue where human interaction with the environment is a significant factor. So it's fairly well understood that the harmful algal blooms are being driven by the amount of nutrients running off primarily from farming going on in northern Ohio. But it's not exclusive to that, and it's not always clear as to where exactly that's coming from and what the source is. So those are all active areas of research, and how you might address that, but it seems to be that's one of the primary reasons why is the amount of nutrient runoff in general. One of the primary reasons why harmful algal bloom existence is growing over time. So that's one of the biggest research topics we're looking into in the Great Lakes. Another question?
How are you using the ESP to analyze the toxins from nature-based?
Are you asking how the ESP works? Yeah. So it's not my area of expertise, and so I can only relay what I've been picking up myself. But there's an assay. So basically, they're like, I think, 60 little pucks in the device, and it rotates on a carousel. So it takes a sample of water, filters it, and puts it on this little assay, and then the assay will respond to that specific type of toxin. So that assay is developed by actually Steve Fleur's lab, who spoke previously out of NCOS, in partnership with them out of Charleston, South Carolina, and they developed those types of assays for a variety of toxins. So we're working with them on the type of toxin that exists in our geography, and this ESP applies that water to that to that assay, and then takes a picture of it, and then it actually emails that picture back to the laboratory. So this is all happening right remotely, it's deployed, and by looking at the picture and seeing which parts of that assay light up or respond to that toxin, you can determine the level of toxicity in the water. So it can be used to do, this device can do different things. It can look for other toxins, or be developed to analyze samples in a different way, or even capture them, for example, and bring them back for genetic analysis in the laboratory. That's all an area of technology development.